Several manufacturers are now incorporating different forms of four-wheel steering into their vehicle designs. This ranges anywhere from light-duty trucks all the way up to high-performance supercars and everything in between. Four-wheel steering can effectively reduce a turning radius of a vehicle at lower speeds, and it can improve higher speed maneuverability on a vehicle. Two-wheel steering maintains a straight position on the rear wheels, on the rear axle. With the front wheels turned, the vehicle is going to make a turning radius. It's going to turn about a point on a circle, and that turning radius will determine the size of that circle that that vehicle is able to maneuver in. With four-wheel steering, at lower speeds, opposite phase, meaning that the wheels are going to turn in different directions in relation to the vehicle center line, front to rear. So normal two-wheel steering has a given turning radius. Four-wheel steering, in the opposite phase, it allows the vehicle to turn sharper while maintaining the same physical limits that the front has for its turning radius. Opposite phase steering helps the vehicle's maneuverability in low speed situations by turning the rear wheels opposite of the front wheels. This results in a tighter turning radius and allows the vehicle to maneuver around obstacles at lower speeds. This is more helpful when navigating through parking lots, parking garages, parking in driveways. Driving at low speeds when making tighter turns and maneuvering around obstacles is going to be more crucial. Same phase steering turns the rear axle in the same phase as the front axle, and the vehicle maintains more of a straight ahead position while shifting over to the side a little bit. Now, rear wheels aren't going to steer as much as the front wheels. They may steer up to about 5 degrees. Same phase, we'll move the rear axle in the same direction as the front axle. So the front wheels are turning in the same direction as the rear wheels and is most beneficial at higher speeds. Think about changing lanes on the freeway. Rather than the front tires leading the vehicle over to the other lane and straightening back out, same phase steering would decrease the driver's effort in aligning the vehicle for lane position when changing lanes at higher speeds. So it can shift over as the driver is changing lanes. And at some point, if the driver wants to turn more or maintains turning, the rear axle may go back to its regular phase and just steer on the front axle again. The main input on the steering system for how the system is going to react to the driver's input is going to be based off of vehicle speed and the steering wheel position. As speed increases, the phase will change, and as the steering wheel position changes, it will adjust based off of the driver's intended direction. As the driver's input to the steering wheel shifts just off of center by a few degrees, that's going to enable the same phase steering. Light turning one direction without much more input is going to maintain a mostly straight ahead position. So the four-wheel steering system will likely be in same phase. As the driver inputs more turning angle into the steering, the rear axle will go back to its original phase, and it's only going to steer on the front axle like a vehicle without four-wheel steer. When the steering wheel position is at more of an extreme angle, it's likely going to be at a slower speed. At this point, the system will turn the rear wheels in opposite phase for tighter turning. Depending on the vehicle and service information for the system, the driver may have the option to disable or enable the system from functioning. So as you can see, I'm flexing my art degree yet again. And on the left is same phase steering. And this shows the wheels pointed in the same directions from front to rear in order to operate the vehicle at higher speeds. Opposite phase turns the wheels on the front and rear axles opposite of each other in different directions to increase maneuverability at lower speeds. So think about same phase steering at higher speeds like lane changing on the freeway, and think about opposite phase at lower speeds for maneuvering through parking lots, parking garages, in and out of driveways, and tighter turns. The 1987 Honda Prelude was one of the earlier vehicles to incorporate four-wheel steering into the steering system. However, on that system, it was not controlled electronically. It was done so mechanically through a planetary gear, and based off a steering angle, would mechanically position the rear steering rack into same phase, back to neutral, and then into opposite phase, depending on how extreme the angle was at the steering column. In the GMC Sierra 2002 to 2005 model year, some of the truck platforms were able to be optioned with a rear steering axle. And this was configured much like a front axle. It had the steering knuckles very similar to the type on the Jeep, where the solid axle housing goes out to the ends, and then you have a ball joint up top and a ball joint at the bottom supporting a steering knuckle on the end of it. And this was just operating at very light degree changes with an electronic power steering rack to control the movement left and right to steer the rear wheels. By equipping the rear axle with this option, the rear axle might have been a semi-floating axle or a full floating axle, but with the quadristeer rear axle, which is modeled very much like a front axle, as the steering knuckles are turning, the bearings are incorporated into that steering knuckle assembly. So the rear axle on a four-wheel steer truck is going to be a full floating axle, which increases its towing capacity and can support more load. There's also the potential for more things to wear out. So not only do we have upper and lower ball joints on the front suspension, but we now also have upper and lower ball joints on the rear axle. More moving components means more potential for wear, more maintenance, more cost over the long term. Also, the addition of the electronic power steering rack and the module managing the function of that power steering for the rear axle over time will involve troubleshooting, maintenance, and repair. As those items wear or faults occur, then that may result in different handling of the vehicle, warning systems going active, and the increased cost of maintenance and service on that axle. While four-wheel steering is not a very common system to be equipped on a vehicle, there are more and more manufacturers incorporating them into different lines of vehicles on their platforms. Most of the time you can tell by looking at the mechanical components on the rear wheels to determine if there is a component there that is in charge of steering the rear wheels. Sometimes there may be rear toe adjustment, and it may seem like there would be ability to steer the rear wheels, but they do need to be able to pivot a little bit, and they need some sort of power source to maneuver left and right. So in addition to a toe adjustment, there would have to be a component that would steer the rear wheels. So by looking at it, you can often tell if it's equipped or not. And as always, check service information to see if it is equipped on the vehicle and how the system is supposed to be serviced. There may be safety precautions involved with servicing those systems and enabling and disabling the systems for service. This was a quick one. This was four-wheel steering. Thank you.